Yes.
We are providing the progressive and value added education facilities to the students, which means Professor Dr. Manoj Tarambale sir, who is taking initiative for arranging such type of events for the upliftment of the students of Pune Vidyarthi Graha. With these words, and I wish best of luck to the participants, which is in a large number. Thank you very much.
टाइटल चेंज करूँगा.
Thank you so much, sir, for your inspirational and motivational words.
Video data.
Thank you, madam.
Valuable time.
Thank you, madam. Yes.
करते थे ना. मैम टाइटल Symposium.
Coordinator, student coordinators.
Symposium on ML, AI and DI.
Sir.
Yes, sir. Yes, sir.
With your permission, can I leave because I have one more meeting after 5 minutes?
Yes, sir. I can understand, and thank you for very much, sir. We will be in touch in coming days also.
Sure. Thank you, sir. Thank you so much.
Yes, sir. Yes, sir. Please, sir. Yeah.
Yes. Thank you, sir. Thank you.
Thank you, Bormani, sir. Yeah.
Thank you, sir.
Thank you, sir.
We have Tejas Soshi and Sakshi Bispute as the student coordinators. In the registration and certificate team, we have Tanmay Deshpande, Sumiran Tode, and Rutuja Gayakwad. In hospitality and documentation team, we have Nehal Sharma, Adish Pulavare, Vinit Parkipalli. In advertisement and publicity team, we have Sahil Davre, Rohit Gadre, and Pratik Koratkar. And this is the final team, last team, quiz team, where Nikhil Khodke and Shivam Dikshit have helped us a lot to set the technical quizzes, finalize the topics for the ideation and the concept work. So thank you, students team again. Now I would brief about the automaton AI. I hope this is visible.
Yes, madam.
This is the company owned by Mr. Bhushan Muthian. So this is the full stack deep learning and machine learning enterprise AI platform company, and it is headquartered in Pune, India. He has Advit AI Labs, and this is the LinkedIn page for that. These are the different AI videos and learning materials available on YouTube channel. And there are applications of AI in construction. We can definitely watch the YouTube videos for their role in construction. We also have applications and challenges in leveraging AI in smart cities and AI in agricultural domain. These are the Advit labs which are developed under Bhushan Muthian. This is the introduction of Bhushan Muthian. He is B from Savitribai Phule Pune University from same department, ENTC. He has done his master's in computer engineering from San Jose State University, California. He's been specialized in embedded systems and AI. His experience is founder, Centilligent AI Private Limited, CEO, Automaton AI Infosystems Private Limited. He is the principal data scientist at creationworks.ai. He is AI ML engineer at Wells Fargo. He has also worked as AI applications manager, Wave Computing, and machine learning engineer at Wave Computing. So thank you, Bhushan, for sponsoring the event. Thakre sir.
Yes, madam.
Sir, can we take 5 minutes break? Mr. A. Unnikrishnan sir is joining in 5 minutes, sir.
Okay. Then we wait uh, till that time. We will call them, ma'am, or they have already
Yes, sir. Yes, sir.
joined in 5 minutes.
Madam, can I leave from the meeting?
Uh,
Because
yes,
I
sir.
have to
Yes.
attend some other
Yes.
function at Samstha.
Yes, sir. Yes, sir.
Yeah,
Sure, sir.
thank you. Thank you.
Thank you so much, sir. Thank you.
Thank you.
Thank you.
Thank you very much. Thank you for your presence.
Hello, madam and sir.
Sir. Hello, sir.
I will be available partly, so please
Yes.
excuse me for that. Yeah,
Yes, sir.
yeah.
Yes, sir.
Thank
Okay.
you. Thank you
Okay.
for a
Thank you
good,
so
nice
much.
opening. Yeah, yeah.
Yes. Thank you, sir.
Thank you, sir. Thank you.
Yes.
Just wait, students.
हे आपला आहे रे. आपला ऑडिओ डिस्कार्ड कर. डिलीट कर.
which enables a huge level of business operation capability. I'm sorry, was somebody asking something?
No, sir. No, sir.
Okay. I'm sorry.
No, sir. That was by mistake.
Okay. the all of this thing put together, if I try to summarize, essentially we are going to be in the age of AI, where there will be a trillion plus connected things. We're already into the path of this, right? Like I was trying to tell you earlier. 2 million plus factor the Internet of Things, connected, working together, AI enabled, 13 million plus stores. All of these numbers are big, right? 570 million odd farms which are getting AI enabled, predictive agriculture enabled, call center agents are which getting even predictive analytics to support you. Majeshri, there is a comment here saying slides are not visible. Dr. Meenakshi, is that the truth for everybody or?
For us, the slides are visible, sir.
Okay, there is a chat comment which I saw. Okay, you're seeing it, right?
Yes.
Okay, perfect. So baseline, we are in the age of AI and will be having connections from these IoT devices exploding in front of us, operationalizing for us a world which will be completely different from what we can envisage currently. Let's move to the next slide, Madhusri. Now, if I try to break down over the next few slides, what is AI? Then this data can then leverage its training, AI trained models, to perceive the environment, reason with it, and then the actuators in that device. In this particular case, it's a mechatronical robot, right? So it can then operationalize its actuators and react with that environment to execute the plan required or the action required for it to achieve, and then continue the path. This is essentially an operation, right? This is going to be true for any domain in environment, whether it is Madhusri, you keep moving as you understand the flow. Whether it is a car, which is essentially a big robot driving in an autonomous environment, right? Sensors sense the environment across the road, understand what's happening towards it, and move the car forward as if you are driving it instead the AI inside the car drives. True for a device like an Amazon Echo or Alexa or any of those products which you're currently seeing in the market. The process remains same. Sensors capture the environment, the neural networks, which has been trained into that particular solution delivery, perceives, understands, and reasons with that environment, and the actuators, in this particular case, the audio microphone and the speakers, then react with that environment as per the plan, and then the path continues. Can you move to the next slide, Madhusri? Again, same true for a medical devices environment or any domain, any environment. The base construct remains the same. Can you move, Madhusri, please? What I want you to do on the next few slides is to break this thing for you so that you understand how does this happen, at least in the first part of it, where you build the model, right? So the process starts baseline with the core ingredient for AI, which is data. So in an organization or in a research environment, you capture data for that particular transactional operations and others for that particular business or research environment. And think of it like raindrops. You collect all of them across the spectrum of where the rain falls into a lake, right? And then you do analytics on that data which you have captured. You might do that on slices of that data or the full data itself based on what is the size and nature of that data. When you have a particular objective in mind, you try to then extract features out of that data to make sense of it and then use that into a model which will be able to do for you what the intention of the problem which you are wanting to solve. So you then apply machine learning in AI to build a model which attempts to solve the problem which you want, and then you validate that model and ensure what it was supposed to do is what it is doing, right, against a new set of data. And then you deploy that into the environment which you want for it to operate, right? This is the the horizontalization of the building of the model processes, and the blocks are what I've shown for you here. Now, as students and researchers, you've already been part of this process, right? Underlying to this is the tools which is there in the ecosystem currently, which enables you to do this. So for data analytics, you'll be using tools like Pandas, Rapids. Rapids is an accelerated tool from us, equivalent of Pandas. Drop-in equivalent almost, but accelerating that at such a high, better pace, and a full-fledged end-to-end platform for data analytics. You've seen Spark, you must have used Graph Analytics, etc. Right? In the case of machine learning and deep learning, use frameworks like TensorFlow, use tools and libraries like Scikit-learn, and then algorithms like XGBoost, etc. And then to build and validate the model, you will use models like CNNs, LSTMs, BERT, GANs, advanced models like that, and then understand the architecture which you want to deploy that in, and deploy that in and get it operated against the new data. Let's move forward, right? So if you think about it, after you build a model, you deploy that into the production environment which you want. I want to take a minute for you to build out two components out here. So let's hypothetically assume that you are planning to build a model which will understand if a door opens and anything comes inside, and the model is able to recognize what it is that has come inside and open the entry for that door for that particular thing which is coming inside. Now, typically in a non-AI world, you would achieve this with a security guard or a door operator or whatever you'd want to call. What you're doing here now is you've captured the data for that using multiple video images of what are those, objects or animals or people who would allow entry into it. Train a bunch of neural networks with that data to make it learn and understand what is that is allowed entry, what is it not that will be allowed entry. Then you will connect that neural network to the test data and check if it is actually performing as per the original expectation. So first you train that with the images and other data which you have given it, make it ready, combine those networks which you want for that, and then test it against this data, right? That core component is called the training of the neural networks and combining them, right? That needs huge compute power. And that compute power is a demand, right? Rather is exploding. It is also challenged by the actual baseline model which you've used getting better and more complex. So it's a continued path. Now, what's the challenge for the semiconductor industry out there is typical computer industry has been demanding, the demand from the ecosystem for the typical semiconductor manufacturer and the industry has been based on the Moore's law expectation, which we have ourselves put across, that, okay, we will give you double the power next year. And hence, the world would expect that to happen, and you will continue to build applications which will take advantage of that semiconductor power, which will come next year. And it has been growing like that. Now, we took it for granted for the last 30 years plus, and it's been unbelievably amazing, right? We have given you double the power for the last 30 years, but it started tapering off. So the only possible way now is to look at a differentiated, accelerated computing parallel processing approach to achieve that power. But at this point of time, we are further challenged with another problem, that this network requirement models which need to be trained now is growing at a complexity which is 10x. So instead of double the power requirement, compute power requirement, they're literally demanding 10x the power requirement. So underlying compute is enormously challenged to deliver to this demand, and hence that's your core building block, data and the compute demand, which is required to train this neural network. So once you train the neural network, your problem now is to deploy that into the environment which you want so that it'll do the job for you. In this example which we've been talking about, now what you want to do is you want to ensure that this model now is able to open this door for your whoever is the right people or right things which wants to come inside, and not allow that for what it is not there. So what you will do probably is to create a a mechatronic device which will open the door based on the sensor inputs, which it comes in this case from a combination of, let's say, video, camera captured, CCTV captured video, and audio of that that person talking or whatever. And based on it being the right enabled entry for, or rather authorized entry for that thing or person, it'll open that door. Otherwise, it will not open it, right? So you need to now think about the deployment architecture for this, devices required for that, and then connect that into that place, and then test it with that new data. And then once it's done, you are putting it into production. Now, simple it might think, but the baseline point for you as a student who are wanting to apply this is that once you train this data, then you need to, as you train it, you need to think about the deployment architecture which it will actually operate in, and build the capability for supporting that deployment in that existing environment which it is supposed to operate in. So you need to factor in that operational environment, the latencies which it needs to support, and the architecture to effectively deliver that outcome, right? And then you improve the model in a continuous loop. One critical thing out there when you think about that part is the beauty of this whole thing. So think of this again in the same example, right? So if your job now was to put a security guy out there to ensure this, with one training of this neural model and creating that, you're in a position to now ensure that operation is now transferred into an AI-enabled device. So it will open the gate automatically. And the beauty is two simple things. It will do that continuously without any tiring 24/7. Because neural network will only improve, there is no fatigue in it, and it will continuously operate it at the same efficiency or better. Compare that with the security guard situation. That security guard for a minute takes the eyes off, gone. That particular instance on that particular 5-minute operation is closed. He has to take breaks, he has to sleep or she has to sleep. And more importantly, if you have one more door to maintain, you need to train and enable and process, understand and monitor that new security guard. With this process, one, you're replacing it with an efficient thing which will never ever fatigue. Second is you can replicate and build a second security guard equivalent with just a click of copy. And you can do that millions of times. And hence the robustness of this application environment, which is why the transformation will happen and industry will adopt and business is so eager to apply this. That robustness which will enable it to have the scale and deliver it with the efficiency, and also train the new one with changed data requirement in a new environment. Because the same once it's trained now in this door, retraining it for another door, a little bit differentiated entry, is basically just training that original model with new data, right? So it's unbelievably amazing what we can do and achieve now. Mansi, if you could move forward. So the second component of that, the deployment part of it, is what we would like to call, for your understanding, the inference part of it. So two core components in this whole build and deploy: training and then inference, right? Now, this is true in any domain which you can think about. So for the training part, you need as an underlying core construct the data, huge amounts of it as is required for this thing, the supercomputing infrastructure required to train that models, combine them and retest them with that, combine this thing and validate them. And then the deployment environment, you need hyperscale infrastructure in the cloud if you're going to do the inference in the cloud, or you need the device itself to have the compute power in it to do the inference of the surrounding environment which it is supposed to infer on, right? Or a combination of both cloud and the edge devices. So that's what the underlying infrastructure is supposed to show. And this is true for any domain, whether it is in drug discovery, where you train the neural networks to understand docking, for example, and then discover potential new drugs and inferring it with the new molecule parameters, etc. Right? So that's in the case of drug discovery. Can we move forward, Madhushree, please? Now, I wanted to take a minute to further break this entire pillar to you, and then give you the challenges and the transformation, the underlying stuff which is there for this, and what you need to be prepared for if you want to learn this environment and apply this. And then based on that, maybe two things you should factor in. One is understanding the transformation, the directions of that, and the competencies which is needed for that, and also understand the infrastructure environment which you will need to be either getting provision for your institute or from wherever it's required to achieve the goals which is required for that. Because the only thing which is there underneath in this whole of things is these three core simple things: data, the compute required, and the neural network algorithms. Algorithms are free of cost. Everybody who's building something in AI first world is literally open and giving it to everybody else. So one beauty of this whole environment is you are in a position to get the latest and greatest almost in real time as it happens anywhere in the world. Second is data. Abundantly available because of mobile internet now, and as students and researchers, you have a far better access to it than even the enterprise. The infrastructure which is required then to work on both of this is compute, and you should understand what is required for you and go behind getting it either from the cloud or your on-premises infrastructure. To enable that is what we are enabling. Now let's break this down, right? So data is the core, the new oil for the AI enablement. It's the new source code, right? Now, one thing which I want you to appreciate out here is the pace of this transformation and what is hitting us. Now, big data has been there for some time now, almost 10 years on with Hadoop starting the revolution for us, right? But when Hadoop was conceived and constructed and the big data revolution started, all of us were in the perspective that, yeah, data will grow from MBs to gigabytes. The perspective was that, right? And then the outlook was, okay, from an infrastructure, rather the data engineer and data analytics person and the management, the outlook was, look, I'll capture data this much, but I'll at a point of time work on this much of that data. And I will do that, let's say 1 week later or 6 months later to understand from that history what has happened. So it is more meant as a sort of a history analysis and learn from that. But what has transformed at AI and the pace with which you're moving forward is gigabytes to exabytes, exponential jump up, right? And then we want to now not look at the sample data. We want to look at the full data, right? And full data at exabytes of order is a mammoth differentiator than what we were originally thinking of the big data requirement itself. The other third parameter is, instead of wanting to analyze this in the future, we want to do it in near real time, or rather real time itself, be able to give the required business transformative value to your either business or to the customer. So for example, think of this as in the case of, let's say, browsing the web. The web builder for that particular website and the organization behind it literally wants to craft the journey of the user who comes on the web. So it means it needs to be able to predict the movement of the person who's coming on browsing on that website, and then more importantly, guide his next action almost invisibly so that he acts or she acts on that website the way they want it to act and work, which means it needs to real time enable the data analytics and transform that thing for them. So real timeness, and this you apply in any other field also, right? Whether it's in autonomous driving or anything which you can think about, shifting from future to near real time, right? Essentially, the underlying parameters for big data has changed, become bigger, become real time, and has become immediately transformative into not an analysis of the history, but a predictive action for modeling the future, right? So that's the challenge which is involved in transforming the data analytics part itself. Now, once you have engineered the data and done the analytics on it, you move into extracting features out of it into building your model, right? So this is the core AI place, right, where you apply machine learning and deep learning, computer vision, and natural language understanding, which is the two big components of that, and then work on that model to build a predictive model. What has happened in this field is from the traditional approach in machine learning, which was an expert-driven approach, right? If then else outlook, which we studied for almost 50 years now, to a completely differentiated data-driven approach where we're using the data to train the neural network model, right? And then once that has transformed that potential of result for that, it has just been an explosion of that models happening. And we have a few slides which will show you that the model complexity is exploding at a million order plus complex depth, which means if it was, let's say, million parameters for a language model 6 months before, now it's almost billion parameters in hardly this much time. In fact, actually, it shifted from million to billion and then multi-billion, almost like 150 billion, to now almost immediately hitting a trillion order parameter complexity in the case of natural language understanding. So essentially, this block needs you to understand the latest and greatest, because the model complexity change is essentially immediately making the older model of no use or so outdated, right? So you have to take the latest and greatest, learn that immediately, apply understanding of how to train it, and then leverage the underlying compute needed to train it, because you won't be able to catch up otherwise on that. So in this block, what you need is agility to learn those neural networks as they come, and the infrastructure to apply that, and the compute power which you beg, borrow, or steal, and achieve what is required for that. And then with the outlook of deploying that into the architecture and the environment which you want. At that particular point, and this is one area which is absolutely critical when you're going into production. One of the biggest gaps for Indian entire environment also. And this is also an issue of how we teach, right? If we just teach somebody to build a model, but not deploy that into a production environment, it's not even half job done. So you have to as well understand how to optimize the models, combine them, optimize them, and deliver that into the infrastructure and the operational environment which is supposed to work in. You needed to have that thought through, and then you needed to have the identification of what it will need as compute requirement in that edge environment, either on that edge device itself or in the cloud, so that it operationalizes. Now, in order to do this, there is a bunch of issues, architectural construct on one side, and then how do you operationalize that model? So in many cases, whether it is in autonomous driving or in robot or in drone creation, you won't obviously be able to test the physical prototype in real world, because the complexity involved in that is too much, and physical prototypes are costly, and the environment is not going to be sufficient to train it in all the permutations and combinations which you need. Simply put, if you want to train an autonomous vehicle to run on Indian roads, you can maybe get one footage of one road, and then you can't even go attempt to get that footage of that road in multiplicity of conditionalities. Nighttime, low daylight time, running in rain, in snow, whatever, right? So and then explode that to across roads. So which means you need to simulate that in a computer environment with the machine in the loop or human in the loop, right? So that part and the learning to achieve that is what you need to do in the inference part of it, and then capture all of that, construct in such a way so that you can deliver that as a service, right? So that's the final block of this whole thing. You need to, if you're wanting to build and deploy AI models, you please ensure that you understand this full flow, and then you focus your actions on one or two areas and learn to collaborate with the multiple other people who will work you in this environment. But you please ensure that you capture and build and nurture in yourself the capability for this across the spectrum, and be agile enough to learn on this on a daily basis. Because by the time you sleep and wake up, the neural network model has changed, right? So I just thought I'll break down this block for you and tell you this is what is possible. But the exciting thing about this is happening in the real time, in the real world with practical possibilities. And more incredibly important is that what you do is as good or better than what a production team in any part of the world, in any big company can do. You have actually better possibilities. What I wanted to now do is take a minute to sort of drive your imagination. What is possible with this, right? To simply put, right, I want you to think through in three components. One is, please understand that everything and everybody will factor in AI for what will happen tomorrow. AI first will be a strategy by businesses. AI first will be a strategy for research. And AI first will be a strategy which you will apply in everything which you want to do personally also. So it will be an AI first world which we'll move in. Now, to synthesize this information, let me try and attempt to give you a perspective on this, right? So if you think through the human evolution and now what we have gone through and divide that into stages, right? And I'll do a rough job of this. We were nomadic in the very earlier agrarian, agriculture-driven type of stages. It lasted thousands of years for us. The knowledge growth was very, very low. We were involved in trying to build better capability for us to work together, primarily, right? So that we can, as a community, achieve our goals. It lasted such a huge amount of time. And if we quickly shift into the next era, rather, shift 1 or 2 eras further into the industrial age, we were thinking about, how do we improve productivity so that the capital employed can be better put to production requirement. So we were in the industrial era where we were thinking of operational requirements when people, how to make them more efficient, etc. Right? And that lasted for hundreds of years, around 100, 250 odd years, right? We're still evolving on that, but that's been the depth of it. So thousands of years, slow improvement to industrial era, amazing improvement, hundreds of years. And then over the last 25, 30 years, we moved into the information processing era, right? In here, our base construct was, how do we fast process the information so that we can transform that in knowledge and then take advantage of that? So information processing became the baseline building block, and the construct underlying change to how do we make that process faster, right? Lasted 10, 30 years odd, right? So from hundreds of years to just decades. The AI era is now on our path, right? And this is going to be so transformative, and the cycle is shortening. Think about what happened, for example, with the technology evolution and infusion of mobile itself. From something which would have taken decades, it's hardly taken few years now, right? Mobile from wireline, where we were, to now it's penetrated to the level of depth which we have almost around 90% in just hardly 5-6 years. We think AI will penetrate at that level in 2 to 3 years time frame, which is challenging because you won't even have time to learn to apply. So you don't have time to crawl, run, and learn and all that. You literally have to run immediately, because your typical BTech cycle, for example, if you think about it, 4 years to teach you. We don't have the time. So you need to apply and learn simultaneously, right? Second thing, which you think through when you look at all of this is, through this revolution, still AI, our tools, we obviously took advantage of tools in this path forward so that we can augment our limited senses. We were augmenting our muscular capability. At first, we learned to use other people's muscular this thing so that we can leverage. And then we learned how to augment that using machines for our muscle up, our arms, legs, all of that machines made us possible. We can literally move mountains with that now. We can see the stars also because we augmented our eyesight. But in the AI age, we are basically just augmenting our mind, which is unimaginable possibilities open with it, right? What we have achieved till now was to augment everything physical in us. But now we are augmenting our mind with artificial intelligence. Possibility is unbelievable. Second thing which you need to understand with that is, when you put intelligence in something, whether it's a security gate or your drilling tool, it completely disrupts that environment. Now, to make this disruption understand, what you're essentially saying is that your tool can now intelligently operate on itself. Now, this transforms everything. So think about it like this. Now, if you want to drill a hole in your room for hanging your photo, your new generation AI-enabled tool You're basically telling it. You're not lifting it. You're not, drawing this thing and finding where exactly you need to drill that hole. You're telling that tool, that driller, hey, driller, I want you to drill in the middle of this room at exactly this height. Our tool immediately lifts it, goes to that place and drills. Now just think about the disruption which will put into every field, from your security gate to anything which you can think about, your fridge to anything. So that's the transformation which it will drive for you. It's just not easy to imagine. But the goodness of this is you are in a position to take advantage of this, learn and be part of this now, if you follow this path in every domain which you can think about. But it'll also transform your job and your requirement and the skilling need which you want. If you extrapolate this, your tomorrow's car designer, builder, mechanical engineer is not going to be the person who will actually build the car the way the current mechanical engineer does. It might be an artist who will do that because the core mechanical engineering function will be AI. So the artist will be saying to that AI, hey, I want a car which is of this shape, this power, and such that it does this functionalities. The job shifts. Right? Please understand this transformation as you grow into your career, as you plan your path forward. That's what I wanted to say in this part, so that you sort of factor this in as you move forward. Mansi, can we move into the next slide, please? And actually, I've covered to an extent all of this, but this slide I wanted to put in perspective for you the pace with which this is happening, which is in front of you. Right? In 2015, AI could recognize images better than human beings, which essentially, if you put this into layman terms, I give you an image, you and me. If they're able to recognize hundreds of the images as correct, 99% of the time, AI was starting to do that at 100% accuracy is better than us, right? This was from a situation where the AI's accuracies just a year before itself was hardly in the 60, 65, 70% ranges. 70% ranges to crossing over from us. And the impact of that is essentially you're trying to say that the capacity for the AI now to understand, let's say, from a radiology image, whether there is a tumor or not, is far, far accurate than a radiologist itself. I'm not saying that the radiologist will be replaced, right? I'm basically saying the accuracy of that particular understanding we crossed over in 2015, right? 2016, we can do that for language translation. Just a year later, we could do that in recognizing speech better than human beings. 2019, we could build realistic images and speech. AI could do that. Right. In fact, if you saw our video, that whole video was composed, the music of that was composed by AI. In 2020, we achieved superhuman capability for diverse set of language tasks, from summarization to recommendation. Now we are entering the era of AI plus metaverse. Sorry, guys, I think there is a disruption. Madhushri is probably not able to share the screen. Can you guys give us a minute while she rejoins? In the meantime, yes, probably I can take a few questions because I think I might have taken a little bit longer than what I intended to do. So, Dr. Meenakshi, if you think I can take a minute, 2-3 minutes till Madhushri joins. Pardon us for this.
Yes, sure.
But if there's any questions in between, I can answer in the meantime.
Yes. Dear participants, do you have any questions?
Sir, I do have a question. Kaushik Khare from MMCI. My question is, we know AI might take a lot of jobs, but is there a way to create more jobs instead of like diminishing the opportunities?
Actually, Kaushik, I think your imagination is not correct. And sorry, I'm not meant to cut you perspective as a negative, this thing. I'm basically trying to say that you have not imagined it properly. Let me try to play this out for you, right? And think about what has happened, let's say, with OTT platforms or with e-commerce, right? Now, e-commerce has really taken away a bunch of the stores opportunity. It has taken away, and please don't quote me or anything, I'm just trying to brainstorm with you here, right? It has taken away the opportunity for a lot of people who are working in that stores. But on the other side, it has transformed your and my life by delivering to you immediate and real time many places and many things which are others taken weeks or whatever, and the convenience. But parallelly, it has also given jobs to millions of people in that business now, right? And this is true, always has been true for all our technology evolutions. With the advent of AI, it's actually doing two simple things in my opinion, right? And please don't hold anybody else, this is my personal opinion, right? I think it will create huge number of better opportunities in ways we can't even imagine. It'll, for example, in the case of metaverses, right? It'll create metaverses, and there is a huge amount potential for creating avatars, creating this thing, and what AI business models will enable. Plus, it'll take away from you what you really otherwise needn't have done, and which is routine, which is the job for the machine to do, because it'll do it better than you, and you shouldn't waste your time doing that. So, Kaushik, the perspective shouldn't be, hey, it'll take away from me, rather it'll transform me, and obviously I need to adapt to the change. Because in any one of these transitions, there are people and businesses who will suffer because they are with the existing modality. But in anything in life and in technology, you will understand change is a constant. It's not for the bad, it's for you to adapt to that change and understand the changed environment. Now, again, let me take a minute more to explain this, right? Assume that you are an agriculture farmer in the 50s even, or 60s even, or 70s even, for that matter in the 90s even, right? You are farming with bullocks and leveraging animals to support your farming process. And your neighbor is doing that with tractors and with mechanized operations. Do you think it's taken away the farmer's job, or it's improved the conditionalities? Now, if he didn't adopt it, he wanted to continue in this, he'll obviously suffer. But if he changed his thought process and adapted, it would be better. But that's always going to be true for anything, not just AI, right? Did I answer your question and sort of give you a perspective, Kaushik?
Yes, sir. Thank you so much. Thank you so much.
Okay, let me try and call Madhusri. She's a little bit in a different place from me, and we are living in this virtual world almost now. So let me see what's the problem and see if I can get her back, or I'll try and project this from my own screen. Give me a minute, please.
Yes, sir. Sure, sir.
So can I ask one question?
Yeah, please go ahead.
Yes, sir. So actually, when we talk about training a neural network model with billions of parameters, so currently, how the challenge of the training time means training a neural network model with so much of huge parameters is taken care, because
That's a point, Vaishali, which I wanted to cover in the next few slides.
oh yes sir.
Sure. But baseline it is that you need to provision, you need to understand that compute requirement and try and get yourself for that compute. The good thing is access of that is enabled using compute in the cloud, and then you need to push your infrastructure environment to be robust by either demanding it or getting it somewhere. But that's a differentiator, right? I don't think we might get Madhusri back immediately. Let me try and share the screen from my side itself and take us through this again, right? Sorry about this disruption. Huh?
No problem.
Okay, so we were here, right? Right. So actually, Vaishali, to explain the problem to you and the point which you have raised is what's there in the left side of this graph, right? And I want all of you to understand this. What is there is basically the evolution of the natural language processing underlying models. From just 2013, which was ELMO, which was a 94 million parameter complexity model, to evolution of BERT and then GPT-2 and moving forward from there. The graph depicts the year on the x-axis and the parameter complexity on the y-axis. Just think about it. What you're seeing there. It's a hockey stick growth, and baseline, it has grown from 94 million to 1.5, 350 million rather, in just a 7-month period. And from there to 1.5 billion in hardly another 6 months later. And from 1.5 billion to something like 180 billion in just another 1 year time frame, right? GPT-3 is 175 billion. Now, GPT-3 accuracy levels are seriously good. It was doing it at better than human efficiency. But when you want to do that into a nuanced model, right, nuanced environment where the model or the, let's say, chatbot in this particular case really understands the context and the nuances and the subtlety involved in that environment, which is what you and me will do when we are talking to another person, this is still not capable. So last GTC, and I'll explain to you what is GTC, this November in our technology conference, we announced a new model which is at a parameter complexity of 800 billion, right? So which will enable you to train other GPT models so that you can do the nuance required for that. Now, why is this nuance required? Because now think about it like an application environment. You are talking to, let's say, you're a chatbot, want to create a chatbot to, let's say, support a suicide line. There is a huge amount of advantages for creating a chatbot to do that with an avatar involvement, avatar which is emoting the features in real time, compared to a human itself because of security, privacy, better distinct issues, response times, etc. But it is never possible because the emotional person on the other side would say something, chatbot would just not contextually understand that. To achieve that nuance, you need this quantum jump of parameter complexity to achieve it. Now with this, you can actually achieve it. But the problem is it's transformed the complexity at that order. And to train that neural network now, you need that compute power. That's going to be the story in this, right? But to put this in perspective to you one more time, the AI first world essentially has changed the underlying construct of what the operating environment for us in that period of time. So from an information processing agent where we were thinking about time to solve that problem from process it, we have moved into AI first world, AI world, right? Where none of the constraints of the capital environment is no more there. Capital will not be a problem. Raw materials will not be a problem because AI will solve all that. AI will find a way to build abundant power for you. AI will find a way. So none of the limitations of the earlier environment is going to be limitations in your environment. Your raw materials has changed from data to compute. So you obviously need to provision for that, right? So hopefully, Vaishali, that explain to you and also make you understand why this is so much a powerful technology force and the changed parameter underneath that. I'm going to read you on the right side of it, but basically it's changing and transforming our life across all of these components, right? From chatbots to drones to the drug discovery to walking robots. Now, I want to take a minute now to put the perspective from where I come in and this original question of this compute part of it, right? So my company, NVIDIA, has been built with this philosophy that the underlying core construct of compute is suboptimal. We've been building on a van Neumann architecture, compute CPU connected to interface connected to storage architecture, which is what you're seeing on the CPU environment, a big brain, right? But works serially. And the problem with that is it just cannot solve in time when a huge amount of operations is parallel required. For example, in the case of graphics, it needs to compute the millions of pixel points which is required to display that image. A CPU type of a compute just doesn't solve it. So we built GPU, which has small brains, but thousands of them, which can do a particular task in near real time and combine them all to give you the output. So bang, you can get your graphics output because each pixel point can be literally calculated by one GPU core, and you can do all that simultaneously and your graphics now evolves. In the case of AI, it's exactly that. You need thousands of metrics multiplication simultaneously to happen, millions of parameters, right? So millions of those things to simultaneously happen. Hence, accelerated computing, right? And we think this approach of combining CPU with a GPU is what will solve the path forward for us for the situation where Moore's law is tapering off. And we've been doing this for the last 10 years now. Instead of giving you double the compute power, we've literally given 10x the power and grown this from what we were to give you a million plus order of potential capability. Hence, you're able to train this neural network. That's what our pedigree has been, right? So what we do is to enable you with compute, which can solve what other computers just cannot, and then build you full stack end to end to support that in multiple domains so they can get to your job faster, whether it is in AI, high performance computing, and within nuanced areas of AI and high performance computing. So I won't go this into detail currently, but just understand that the core underlying compute for both the training and the edge environment, single platform, hardware wise, and then the supporting stack which is required for operating for you in every one of this environment. Instead of telling you this in detail now, what I want to do is to give it to you, right? So we have operationalized, like I told you, right? Data, compute, algorithms are the core construct of AI, but there is a bigger other component, which is the skill needed for it. So for me personally, it's a mission mode approach now to build that skill, particularly from India, primarily because the opportunity for our country is to be a AI have or AI have not. And I think we can be the AI garage for the world and build the AI for the world. And this is your job. And if you apply this, your potential to transform this country is unbelievable. But it's for us to lose also, right? So we have built an IP for enabling training for AI for multiple levels of capability. And for the ecosystem of educators, we're literally giving it free of cost. So and we build this across these domains, and I conduct DLI workshops on a regular basis. So what I've done currently with the COVID coming in is basically put that into an online environment so that all of you can completely take these trainings, full day workshops across these domains, which we put across on a continued calendar. Completely free of cost. So Dr. Meenakshi, I will give access to all your students for the coming forward workshops, and all of them can register and take it free of cost based on the schedules which we put up. If Madhushree comes up online, she will immediately share to you the existing workshop schedules, and then also give you link for this site so that you can keep looking there and register for the next workshops as it happen. Right, and we'll continue to do this so that you can all learn, right? So by the way, the link is already here. You can look at this link, but it will keep getting updated with the latest workshops on a regular basis. Let me try copy this and share this to you in the chat board so everybody can get it. And I'm hoping. Okay, great. So this is for all of you to go there and join. We'll populate that with the revised dates in the immediate term, and we'll keep continuing to populate with more dates so that you can take advantage of it. Now, that's the first part of it. Second part of it is, like I told you, AI is compute, both algorithms and the data part of it, right? We have basically taken an approach which will make your life easy for this. So we have created a registry of all the right models, frameworks, and in fact certain areas, full scripts for a particular industry to solve a problem, which is optimized for the GPU computing environment. So you're working on actual projects instead of hunting these models which are optimized on somewhere else. We put all of this into one place for you so that you can completely take advantage of that and get the latest and greatest from there directly without any pain and completely free. So I'll give this link also to you. So if you are actively working on any projects and have access to compute and GPU compute from either the cloud, through your institutes or a laptop or whatever, please register yourself on NVIDIA NGC and take advantage of the complete scripts which is available out there and download the models which you can take advantage of for your solution from there. So that's the second component. What I wanted to do was so not share this with you from that perspective. What I wanted to do also give you a perspective on what is happening with metaverses. So metaverse basically is a virtual world with 3D enabled realistic avatars and digital twins of physical worlds happening out there. Application will be a cross-board environments, from entertainment to digital twins of factories, digital twins of equipments, digital twin of the world itself, climate models, etc. Now, the possibility for this is unbelievable to collaborate on this. From pure play, becoming an avatar and avatar creators, to building digital twins, to operating that digital twins for multiplicity of environment is possible. We have a platform which enables that with full 3D realism and physical simulation capability, which we call Omniverse. We have just released the open beta for this. What I wanted to give you is full access to this, so that you can quickly go ahead and take advantage of this this in the immediate term and request for beta access for the developer version and get yourself into metaverse. Right, so let me share that link also for you here. And then for the teachers, if there are any teachers here, we have full-fledged teaching kits which will enable you to quickly craft your syllabus from multiplicity of areas, from deep learning to accelerated computing to robotics and data science. These are the best of the best content created with the most known names in those space. 40+ hours of content, videos, PowerPoint presentations, to quizzes, to lab sessions, etc. And all of them completely downloadable and free of cost accessible to you, so that you can use this and you don't have to reinvent the wheel for your particular course. And what is more incredible is that once you download this teaching kit, we are also giving you, using that teaching kit membership, which is free, capacity for you as a teacher to give cloud resource access to your students as much as you need. We give you credits for your students on GPU-enabled clouds for you to request. We're also giving you coupons for your self-paced classes, which you can use from our DLI courses. So if you are teachers there, please use this and download this and take advantage. I will show you where you can get that. Type in NVIDIA teaching kits into the web, and then go into this place, and we are good to go. Just request there, but this is only for educators, qualified teachers, and there you go. Right, and then what I wanted to do was to, so if you were also in the same page which I originally showed you on the DLI, if you as a teacher wants to become an ambassador, DLI ambassador, we will certify you, test you, qualify you, and then certify you as a DLI and then give you this platform so that you can go ahead and from your side train students and your co-faculty, and then scale this across your institute and other students. Finally, what I wanted to do was to invite you for our next technology conference, which is happening in March. GTC is unlike any other technology conference which you've seen. This is a conference which we do annually, sometimes twice in a month, which takes to the world what our customers and scientists and researchers across the world has done on our platform. We typically have been doing this physically, but in COVID, we transformed this entire thing into an online platform. And last conference which we did was in November. One conference, we had around 500 separate sessions in this, and we had 230,000 people attending. Right? So, and these are deep technical sessions. And once you register completely free of cost, you can take the session live, interacting with the student, these people as the live session goes, and post the live session. All of this is available free of cost. Our next GTC we have just announced, which is in March. What I will do is to share you the link for the GTC so that you can quickly register and take advantage of it, both live and on demand. So that's I'll send you the link immediately after this to Dr. Meenakshi, and she can share that to you all post this conference, or if Madhushree comes forward. So that's what I primarily wanted to talk about, and I hope it was useful. I know that I've gone a little bit overboard on time, but really appreciate this, and I can stay on if you are all requiring for a few Q&As. Thank you very much.
Thank you so much, sir. Are there any queries, students? Students, any queries? Shetty sir, could we proceed? Thakre sir?
Hello, madam.
Sir.
Yes, sir. Yes, ma'am. Yes, we'll proceed.
Okay.
Sir, we are very much thankful. It was a very excellent session. I'm Shetty.
Hello, sir.
Thank you.
He is Dr. Prasanna Shetty. He is coordinator with me for the symposium, sir.
Oh, great. Thank you.
Good afternoon. Thank you, sir. It was a nice, motivating, very informative technical session. And really, it was a lot learning for we too, as well as for our students. Very nice transformation importance you have given to all of us in that way. What is the importance of transforming me and ourselves by this AI technology?
Appreciate the input, sir. Thank you very much.
Thank you, sir. Thanks very much.
Abhishek, have you raised your hand? You want to ask something, Abhishek?
Yes, ma'am, I have a question. So, sir, I wanted to ask you that for metaverse, will the hardware will catch up to the software level?
So just like in the case of AI, right? This is another AI-enabled field. Hardware is catching up with the requirement with GPU computing, which we are enabling, but it's a struggle, right? So we are continuously improving, because of which you see the roadmap changes which is happening. But yes, we think we can enable the metaverse, and Omniverse is the platform for it. I've given you the link for it. We are actually in the verge of creating a digital twin for the Earth. So that's possibly one of the most complex problems we have personally attempted as a company, and we hope to realize that in the near term. So yes, we are ready for the metaverse.
Thank you, sir.
Thank you. So I hope you all take advantage of the coming environment and do well. Thank you very much, and wish you all a happy new year and good luck. Thank you.
Yes, sir. I request our head of the department, Dr. Y.B. Thakre, sir, to say a few words about this session. Please, sir.
Yes, thank you, Atra madam. Very nice and very wonderful sessions we could listen from Undi Krishna sir, NVIDIA business head. I have listened to the national conference on AI organized by Government of India, and from that time only I could understand that how important AI is for benefiting the social life. There's in social life also the AI is going to contribute a lot, and that's why I have fascinated with this AI world, DL and ML world as well. And at our department, we'll try to promote all the AI related activities through our coordinator, Dr. MP Atre, and our Dr. PG Shetty sir. And that was why we organized this symposium. And I'm very happy that a great personality like you, who is promoting the AI MLDL through NVIDIA, we could have in this conference. Thank you, Krishnan sir. Thank you all. Yeah.
Thank you. I'll take your leave then, Dr. Meenakshi. Please carry on with the symposium. Really appreciate the opportunity. Thank you, everybody. Take care. Bye.
Madam, hello.
Yes, should we continue the vote of thanks quickly, sir?
Yes, madam. Please.
Yes, madam. Yeah.
Let me take this opportunity to present the vote of thanks. An ignited mind is the most powerful weapon on the earth, above the earth and under the earth, and this is achieved through education. And education is the most proven profitable investment in a person's life. So we all, as a part of Symposium, are highly motivated by the speech given by Dr. Unnikrishnan sir. Now I would like to present the vote of thanks to all. We express our deep gratitude towards Honorable Shri S.P. Redekar, Chairman Pune Vidyarthi Gruha and Director PVG COET GKPIM Pune. I also extend our equal gratitude towards Honorable Professor R.G. Kaduskar sir, Director PVG COET and GKPIM Pune for his continuous guidance and support for organizing these kinds of programs. We would like to express our sincere thanks to our Honorable Principal, Dr. M.R. Taramre sir, who is always with us for carrying out large-scale events successfully. We would extend our thanks to express our sincere gratitude towards our head of the department, Dr. Y.B. Thakre sir, for his valuable support and motivation. We would like to thank the student coordinators, Tejas Joshi and Sakshi Vispute, and their enthusiastic team volunteers. We extend our thanks to all the HODs as well as the non-teaching and teaching staff of our department for their valuable time and contribution in organizing the symposium on machine learning and deep learning and AI hackathon. Our special thanks to Dr. D.S. Bormane sir, Chairman, Board of Studies, and Mr. A.R. Unnikrishnan sir for sponsoring the DLI certifications. Thanks to Mr. Bhushan Muthian for launching AI Hackathon and sponsoring the prizes for Symposium and AI Hackathon worth rupees 10,000. Thank you all. We will declare that the virtual inaugural event is officially over. Thank you. Students, any doubts about the events? I request Tejas to speak or give the overview about the events which are occurring after 12:30. Tejas?
So this is Tejas Joshi, and like I said, so this is day one. So basically, on day one, we are going to have concept war. So like we are going to have 3 tracks, and we have made a sheet basically. Just don't forget to check the sheet on the Telegram group. We'll post it soon. So we have made slots. So according to the slots, there are timings given. So just join in time, and so basically that's all for the concept war thing. And to be on the day of ideation, you are going to be given basically an idea, you are supposed to you will be given a topic basically. So you are supposed to basically express your ideas, your overview regarding that basically topic. Implementation, maybe applications, maybe approach regarding that topic. So that's all. And on day 3, we are going to have a crossword puzzle. So basically, as the name suggests, it's going to be a crossword puzzle wherein you'll be given 15 minutes to submit your crossword puzzle. And the one who gets all the answers right and in the least time will win, basically. So that's all from my side. And if you have any doubts, you can contact me personally, or even you can post the doubts on Telegram group. Thank you.
Tejas and Sakshi, kindly put your mobile numbers in the chat box so that students can contact you.
Hello. Yes, Anshika. You can unmute yourself and ask the doubt.
Will we get the list on the Telegram group?
Hello.
Will we get the list on the Telegram group?
Yeah. You'll get the
Okay.
list on the Telegram group. Yeah.
Sir and Shetty sir, should we conclude the meet?
Madam, I think we'll conclude this meet at this point so that we can start our session in time.
Yes.
Of the concept war. Yes.
Yes.
Thank you all of you. Thank you all of you for joining the inaugural session of Symposium on MLDL and AI Hackathon. The competition begins at 12:30 of day 1. So we will meet at that time. Thank you all of you. Good day. Bye. See
All
you.
the best, dear participants.
Yes, all the best for all of you.
We conclude the meet here.